In this video, the learning target I'm going to talk about is I can simplify square roots. So we're going to start with the square root of 4. What a square root is asking you is it wants you to figure out what is the number that when you square it gives you a 4. So if you think about what number times itself gives you 4, well, the answer is 2, right? Because 2 times 2 gives you 4, okay? So the square root's really just asking you what number squared gives you the number underneath the radical sign, okay? Now, to help us when we start getting into more complex ones, I've listed off all the perfect squares here in the right-hand column for all the numbers from 1 to 15. So you may want to stop the video and fill out your chart. I advise trying to do it on your own and see how far you can get. So take like 1 squared is 1, 2 squared is 4, 3 squared is 9, and so forth. And see if you can fill out this chart all the way to x equaling 15. But we're going to use this to help us simplify square roots. So if we go ahead and look at a few examples here, if I look at number 1, it's asking me what is the square root of 9. Okay, so what I want to do again is I'm thinking about what number squared gives me a 9. Now you'll notice that on my list of perfect squares, 9 is a perfect square. And in fact, 9 is 3 squared, right? If I take 3 times 3, that gives me 9. So the square root of 9 is going to be 3. Okay, so once again, just to get the idea of what a square root's asking us is it's saying what number squared gives me 9? Well, that number is 3. Okay. Now, sometimes we have a square root that isn't a perfect square. So if I look at number 2, I have the square root of 32. Well, the square root of 32 is not a perfect square on my list, right? 32 is not listed. So what I need to do is I need to use this property here, okay? If I have the square root of a times b, well, I can separate that to be the square root of a times the square root of b. Okay, to prove this to you, let's just say I plug in two perfect squares. So maybe I plug in 4 and I plug in 9. Okay, so a is 4, b is 9. Well, 4 times 9, well, that's 36. So I would get the square root of 36 equals the square root of 4 times the square root of 9. And if I check this, the square root of 36, well, if I look at my chart, the square root of 36 is 6, right? 6 squared gives me 36. Should equal what I get when I take the square root of 4 times the square root of 9. The square root of 4, well, that's just 2. And the square root of 9, that's just 3. If I take 2 times 3, I get 6. It checks out. Okay, so it is true that you can take the square root of a number times a number and separate it into the square root of the first number times the square root of the second number. Okay, and we're going to use this property to help us in an example like number 2. So if we go back to number 2 here, remember, it's not a perfect square, but what I can do is I can actually factor 32. I can factor out a perfect square. So I ask myself, in my list of perfect squares, what is the biggest number that goes into 32? What is the biggest perfect square that goes into 32? And you'll notice that number is 16, right? I can rewrite 32 as the square root of 16 times 2. Okay, the reason why I can do this is because 16 times 2 is 32. Then using this property, right, when I take the square root of a number times another number, well, I can really separate that into the square root of 16 times the square root of 2. And then I know that the square root of 16, 16 is a perfect square. 16 is the perfect square of 4, so the square root of 16 is 4. 2 is a prime number. It is not a perfect square and it can't be simplified any further. So I just leave it underneath the square root sign. So the square root of 32 simplifies to be 4 times the square root of 2. All right, let's look at another example of doing this. So if I look at number 3, I have the square root of 147. And once again, I want to notice that it's not one of our perfect squares, right? We go to 144 and then 169. Okay, so it's not on our list. So what we need to do is we need to try and find a perfect square that goes into 147. Now, to do this, you'll have a calculator. You won't be allowed to use a graphing calculator like I'm going to use on your test, but you will have a calculator that you can check these. And so what we're going to do is we're just going to try and figure out which one of these perfect squares goes into 147. So if I take 147 and I divide that by 4, you'll notice that does not go in evenly here. If I can show you a little more clear, right? It doesn't go in evenly. I get a decimal, okay? I want it to divide in evenly. So that one's out. If I take 147 divided by 9, same thing. 147 divided by 25, same thing. And if you check these, you're going to find that the one that goes into it is actually 49. When I divide by 49, that perfect square, I get 3. So what that tells me then is that I can break apart this 147. I can rewrite it as the square root of 49 times 3. Okay. And then just using this property from above, I know that if I have the square root of two numbers being multiplied, that's going to equal the square root of the first number times the square root of the second number. So I can rewrite this as the square root of 49 times the square root of 3. I know that the square root of 49 is a perfect square. The square root of 49 is 7, so I'll get 7 times the square root of 3. All right, let's go ahead and look at the last example here. So in number 4 here, you'll notice I have a number out front that's not underneath the radical, and I have a number underneath the radical that's 12, okay? So what I want to do is I want to simplify the square root of 12, and then whatever that simplifies to be, I'm going to multiply by the 3 in front at the end. So I need to ask myself what perfect squares go into 12. And so when I look at my list of perfect squares, I notice that the biggest perfect square that's going to divide evenly into 12 is 4. So I can rewrite the square root of 12 as 4 times 3, right? 4 times 3 gives me a 12. And then I'm still multiplying by the 3 out front, so I just copy that down. And then once again, using this property from above, I can rewrite this as the square root of 4 times the square root of 3 times 3. And then I know the square root of 4. What number squared gives me a 4? Well, that's just 2 times the square root of 3 times the 3 in front. And then this is where the 3 actually impacts the problem, right? So far, it's just kind of been trailing along. But if I take 3 times 2, that gives me 6 times the square root of 3. Notice that 3 is not a perfect square. It's actually a prime number, and we can't break it down any further. So this is the most simplified form. Okay, so just to kind of recap, simplifying square roots. Remember that a square root is really just asking you what number squared gives you the number underneath the radical. And then the other thing you need to remember is when you have a square root of a number times a number, you can separate that into the square root of the first number times the square root of the second number. And when we're simplifying these ones that are not perfect squares, we're trying to find perfect squares that divide evenly into the numbers so that we can rewrite it, so that we can simplify it down.